Good evening, YouTube. This is Flyfish. Right now I'm showing you a cell that I've made out of magnesium and copper using a bit of PTFE tape here, a bit of PTFE tape here, a space for water and galena underneath this central portion that I've lashed together with more PTFE tape so that I can just grab it with this little alligator clip here. This is a purely galvanic cell. There is no zinc oxide or any other electrolyte aside from water and some galena. And this is the voltage here. Here I have some endocool, which is basically 1112 tetrafluoroethane as a refrigerant that I'm going to be spraying on this, which will take this cell to a minus 26.2 degrees centigrade. And you'll notice after doing this what the voltage is. I'm going to do the same thing with a cell that I made with the zinc oxide Epsom salt mixture, and you'll see that there is a definitive differential in voltage output with the galvanic cell versus the other cell. So here we go. So again, this is just a refrigerant here. We're going to spray on this area, and we're going to get it very, very cold, and I'll show you the ice forming on this. You can see the voltage dropping. So we have this going to minus 26 degrees. She's still dropping. You can see the ice crystals forming here. We'll give her a little juice again. So in any event, you can see a very marked decrease in galvanic battery action with the utilization of a refrigerant being applied to the sample. Again, you can see the ice crystals forming here, and I'm sure that it's frozen that. So we'll roughly bottom out right around there. Maybe it'll go a little lower. Now it'll start bouncing back. If we start heating it up, we can accelerate the heat up with a blowtorch, and she bounces back. Okay, so it went from frozen to unfrozen, and you see that effect on the galvanic cell. So again, this is a pure water battery galvanic cell, and that's where you're at. Okay, now I'll do the same experiment, but I'll do it with one of the ostensible crystal cells. Okay guys, this is one of the zinc oxide cells that I've made, and we're showing roughly 1.595 volts. We're going to subject it to the same refrigerant, and we'll watch the voltage, okay? See the ice crystals forming here, so that's frozen solid. We're still showing that kind of voltage. I don't believe this is a galvanic cell, guys. Is it decreasing? Yes, but not anywhere near to the extent. And again, you can see that's fully encapsulated in ice, and we're still showing that. So for what it's worth, what we have here is not a water battery in my estimation. And if you notice, it's still frozen, and if you notice, it's coming back. Now it decreased again. That's interesting. Now it bounced back up. It's fascinating. So for what it's worth, you know, with this being as frozen as a brick as it is, we're still seeing 1.2 volts. I'd be pointless, you know, I have to say, you know, based upon this empiric evidence, this is not a water cell. If I'm wrong, by golly, you know, I'm willing to listen to any and all arguments, but that cell is frozen solid at minus 26, and it's 1.3 volts. So for what it's worth, thought you might find this interesting. Have a great night.